Video. There it is.
All right.
All right.
Hey,
Hi.
David.
Hi, David. Hello.
Hello. Yeah, well, it's great to see all of you. I guess so. Brian, are you all prepared?
Oh, I'm very prepared.
Oh, okay. Good. So yeah. Well, this will be fun. I guess maybe we'll just. I have some. I had a little bit to say at the beginning. Maybe just wait a couple minutes or a minute or whenever it's on call. Kim, it's nice to see you.
Hi, David.
Hi. Wow, it's been a long time. Hi, Ora.
Hi. Congratulations.
Thank you. Yeah, it's late for you, isn't it?
No, it's okay. It's 11.
Okay. Yeah.
Yeah, Kim has threatened. I think he may show a picture like from the very early beginning days.
Oh, wow.
So
Yeah, you should show
I'm
it.
excited to
Actually.
see that.
Yeah.
Yep,
Can you show it now, actually?
sure. I can.
This is a good test of our technology here.
Sure. Can you see it?
Oh, yeah.
Well, when was that?
That would have been 1996 or 7.
Oh, that's a great picture.
Yep.
I just saw Michelle a couple days ago, and yeah, that's really nice.
Wait, is David hiding right behind you, Kim? Is that?
That's
Yeah, I
right.
think I'm hiding right behind.
Yeah. You need to put an arrow over him so people can know who they're.
Yeah, that's right. 30 years has not been kind, right?
We look great.
Yeah, let's see. Yeah, oh, there's David Shortle back there too. That's great. That's such a nice picture.
It's
And
the last
Chen,
of Davids. There were a lot of Davids.
yeah, David's, and there still are. Yeah. Yeah, that's really nice. I heard from Hung Bee, and David and I talk all the time. Oh, there's Chris. Wow, this is a great picture. All right. Well, thanks for sharing. And I guess we're at 1 o'clock. So we can get started. So so Saturday was a really nice day in Western Washington. So I went for this long bike ride to kind of think everything over, and so then I started thinking about computational protein design, and I started thinking, well, like started trying to deconstruct. So there's de novo protein design, and so Bill DeGrotto and Lynn Reagan showed in like 1988 that you could kind of design sequences that would fold up into 4 helix bundles. That was alpha-4. So that was clearly the first de novo protein design. And then Steve Mayo, I think it was around 1997, showed you could like take a backbone and design design amino acids, design packed rotamers. That was using dead-end elimination. And then that sequence would actually, when you made it, fold up into the structure. And then Brian had the idea of doing flexible backbone protein design, because Kim had developed Rosetta, and you could do all this flexible. You could build up protein structures, and then Brian had the idea of combining that with sort of the side chain packings and to do real protein design. And then so I was thinking, well, that's computational protein design, and I think that's about when I got off my bike and called Brian. I called you, remember? And said, yeah. Brian, okay, we have to do a webinar to set the record straight. Would you be willing to speak with Bill DeGrotto and Steve about and you and talking about what really happened? And Brian said yes, and then I said you have to talk about top 7 at this, so he said yes. So Brian's always super nice, so that was great. So then I got back on my bike, and then I was thinking about all the things that happened afterwards, and I was thinking, well, protein binder design, Sarel, and then Longjing, and then Joe and Nate and everybody sort of progressively made protein binder design better and better, and with enzyme design, Lin Jiang and Alex Sangolini, and all the way through to Sam and Anna recently just kept making enzyme design better, and then with self-assemblies like Neil developing, self-assembling nanostructures. I could think of all these amazing things that all these amazing people did. But there was one person in particular I had really had a hard time figuring out what they did. And then well, then I remember some 3-helix bundles and some peptide binding proteins. But overall, it didn't really amount to very much. So then I was like, well, you know, maybe I'm just kind of like some kind of figurehead. And then I started thinking about this. It was a long bike ride. It was 5 hours. I had a lot of time to think about it. So then I thought, well, okay, what do we have? I was like, well, you can have like the captain of a sports team, of the soccer team. But the captain is like usually the best player. So I figured that wasn't a good analogy. Then I thought, well, maybe it could be like maybe a symbol, like a bald eagle for the United States. But bald eagles eat other birds like eggs and just are horrible, you know, they do all kinds of really bad things. So I didn't really like that analogy. I was thinking, well, maybe it's like the Queen of England or something. But then you have to go through all this pomp and circumstance, and that wasn't very good either. And then I thought, well, maybe it's like a coxswain who yells at everyone to go faster. And I figured there was a number of my students who would probably think that was a good analogy. But I don't like to yell, and anyway, I like to row myself. So anyway, I couldn't figure that out. But the one thing I did realize from all of this is that this prize is really a prize for everyone on the line. Like, it's for the whole community. Like, protein design has come just this amazing way, and I think we really can and will change the world. And so for all the people in the Rosetta community, all the people in the IPD, this prize is really for you. So so that was that. So anyway, so now coming back, but we don't have Bill or Steve on the line, but we have Brian here. And Brian, so I just want to set the stage for Brian, who's going to tell the story of top 7. So Brian, as I said, Kim had sort of written Rosetta and then followed by many others, and it was getting better, and Jerry Tsai added side chains. And I think what happened is Brian heard about this and thought, well, maybe we could do flexible backbone protein design. And he wrote to me about coming, and I thought this was great. And so now Brian, can you tell us the story of top 7? And I think Gautam's joining too, so he can intercede in when you if you forget key details.
Yeah, sure. But first, David, you're not going to get off here. This is all for you. This is all a big congratulations to you. I just want to make that really clear.
Okay. All right. Well, yeah. Let's get on with story top 7.
Geez, yeah. So I guess I could just say a couple things about the top 7 project. I guess the idea for it came actually when I visited Seattle for my postdoc interview. So when I came, I told you I was interested in protein design, and I was inspired by the work that was coming from Steve Mayo's lab. And you were really excited to start working on design in the lab. And you immediately said, oh, we should try and design something that's never been seen before. And so I guess right from the beginning, sort of this very ambitious goal that made me very excited. And then when I actually came to the lab, we first had to build some things before we could try and do that. We had to build tools for sequence optimization. So given a protein backbone, find a sequence that will stabilize that backbone. And so to do that, we really built off of previous studies from Jay Ponder and Steve Mayo and others, where we framed it as a rotamer optimization problem. And so we developed a Monte Carlo algorithm that just searches through sequence space and rotamer space for low energy sequences. To do that, we had to create an all-atom energy function for Rosetta. Rosetta didn't have one of those previously. So introduce things like van der Waals forces, solvation potential, hydrogen bonding, and so on. And one of the really neat things about the protocol was that it was really fast. So it was a lot faster than other methods that people were using at the time, like dead-end elimination. And because it was so fast, you could do cool things like you could run it on lots of proteins, and then refit your energy function to optimize the sequences that were coming out to be close to the native sequences. And so that's actually very similar to what we do now, for instance, when we train protein MPNN-like models. So once we had that tool to design sequences for a protein backbone, we then needed to create a protein backbone. And this is where like being in the Rosetta community was just so awesome. We could take advantage of all the work that was being done in structure prediction, and in particular, Carol Roll and Peter Bowers and probably others were working on how can you solve NMR structures with Rosetta. So they introduced the idea of using constraints to drive a protein to fold in a particular way. And so we had the idea we could use constraints to get Rosetta to create a particular fold with just a generic amino acid sequence. The sequence didn't really matter. And so then once you had the backbone, you could then use the sequence optimization tool to find a sequence for that. And what was kind of interesting is that you would have these backbones that look like real proteins, they'd look designable. But when you try and find a low energy sequence for it, you wouldn't get any sequences out that would score as well as native proteins. And that's when we realized we could take advantage of another tool that was being developed in Rosetta, which was protein refinement. So we had the idea of we could iterate between sequence design and refining the protein structure. And by doing those two things in combination, find low energy sequence pairs. And after we did that, we started to get sequences out and models out that had energies comparable to naturally occurring proteins. And that's when started collaborating with Gautam, who joined the lab, and Gautam did almost all the experimental work that's in the top 7 paper. And I think we went through maybe 3 generations of designs. During that time, we were making changes to the energy function, making the repulsion energies more realistic, introducing Tanya's hydrogen bonding term. But at that point, the real hero became Gautam, who really pushed forward, because I was never convinced this was really going to work, and I think he was. So maybe you could just say a couple words, Gautam, about, like, were you confident when you were spending all this time trying to solve crystals that you were actually going to get something?
I mean, I was a young and naive and optimistic grad student, so I think yes is the short answer to that. But maybe just I'll take the quick second to say congratulations, David. Right, this is about you. And even in addition to talking about top 7, when I got to the UW, I was told to rotate in at least one lab that had no interest in the science because I didn't understand it, and that was the Baker lab. And I was of course drawn to the science, but I was mostly drawn to the incredible people that David had assembled, and many of you are here. So it's just that's what this is a testament to, David's brilliance, and then the people he brought with. And so I also made this weird and naive guess at the time where I worked on a rotation project that I pretty much hated, and I was like, this technique is going nowhere, and that was phage display. So I was wrong on that. But then fortunately, David convinced me to work on design. So in terms of the work that we did, it was so awesome to work with Brian, who was himself a trained experimentalist. So he brought in the kind of the view of constraints from NMR. And so much of this project and then the life history of design in the lab clearly has been this iteration back and forth, right? You make a bunch of predictions, but you must go back to the bench to test them out and then re-parameterize them. So I definitely learned that along the way. If I could take a second to make a confession, though, David, I think the statute of limitations has passed on the EHNS stuff. So I can finally tell you, you have your prize, so whatever. When I purified top 7, you called it a rock. All of us have called it a rock because, right, we could basically boil the prep. We could purify it in high concentration denaturant. So that's how we switched to doing it. It was just a huge high concentration guanidine prep. And so in one of those times on the way, I don't know if it was to solve the crystal, the NMR structure, I had a big syringe of high concentrate top 7 in guanidine. And rather than putting it into the dialysis tubing, I put it into my finger. I should have reported it, but I decided that I shouldn't. And so I'm happy to say that in addition to solving the structure, I might be the only person in the world who might have antibodies to top 7 floating around.
That's given you your superpowers ever since.
That's right. Yeah, that's my supervillain origin story. But I will say the other thing that was really cool about being in the Baker lab, and I think everyone here is going to attest to it, was just the amount of trust you put in all of us, David. right? I felt like I was really demanding after I left your lab. It was like, oh, I only want to go to labs so I'm allowed to do whatever I want. And that was a lot of hubris, but that was just because you allowed us to do that. Right. I felt like you were always available, but I could literally go off and spend 6 months in the starter lab solving a structure, and you'd be excited about that. So thank you for affording us that opportunity.
Thanks. So for Brian and Gautam, what was the big aha moment? I got asked that, and then I realized that I have no idea what it was because I wasn't probably there. So, yeah. So Brian, what was it for you?
Well, so I had actually left for UNC before the structure was solved. So, we had done all the design and characterized the proteins and knew they were folded. But when I left to start at UNC, we didn't have a structure yet. And so for me, it was an email. And that is probably the single happiest day of my scientific career when I got that email and could overlay
was that from Gautam?
I was trying to remember. I can't remember if it was from both of you or from Gautam. Yeah.
Yeah, I think for me it was actually it was both excitement and I thought it screwed something up because we got the data set and this was before SAD, right? So this was just a regular prep. And I just tried a molecular replacement with the original model and we got a ridiculously high hit. And I was like, oh, there must be something wrong. There's no way. And so we went through and did it a bunch of additional times. I was like, maybe I poisoned the data set because that was an internal data set. And so I think that was the first level of some trepidation to think we had it right. But then was actually seeing the SAD data set. And because that was at the synchrotron, we could basically see whether we got a refined model right off the bat. And it worked, and already our work was pretty low. So I think I was like, my God, this is actually going to work. I mean, I think we had things along the way. Obviously, right, the NMR data was looking better and better, but I think it was first the molecular replacement, and then actually seeing that SAD density, and that was pretty sweet.
Great, thanks. Well, thank you very much.
All right, so I think now, David, we invited a bunch of people that we can all see right here to each just say a few remarks about what it was like to be in the lab and say congratulations. I'd also just like to welcome, we haven't welcomed everyone here. I think we have over 300 people listening right now from the Rosetta community. So just welcome to all of you. Thanks for joining. We have a list here, actually. This is very organized. Tanja, can you go first?
Yeah, well, congratulations, David, of course. It's really an honor to be part of this celebration for everyone, in particular you. I guess the first thing that I'd like to say is that I felt it was really an absolutely magical time when I was a postdoc in your lab, David. I think when I started, we were about 16 people or so. And Brian, as we just heard, had just written Rosetta Design completely from scratch, building on some of the things that Kim was developing. And then Rich Bonneau and Jerry Tsai and Phil Bradley were making real progress in structure prediction. And Ora and Jeff were there working on docking, and Jens was trying to figure out Rosetta with small molecules. And so I had just developed Rosetta's hydrogen bonding potential, and that started to give us the ability to push the resolution with which we could really model and predict and design protein structures, and in particular looking at polar interactions, which is still a hard problem. And then designing the first protein-protein interfaces with Lukáš Jochimiak and Alex Bullock and Brett Chevalier and others. It was an amazing time. And I think we all felt we were at the very beginning of a field in this magical time. And so now I would say the same is really true still today. I think it is still a magical time. And I think we still all feel at the beginning of a new era of protein design, just what we felt 2 decades ago. And this, David, I think seems to me sort of one of the hallmarks and ingredients of your impact on science, where you really open up new worlds of questions and goals and investigations at every new step of achievement over several decades, right? It does not stop. And I think that is really, really one of the things that's absolutely amazing. And you're creating an absolutely magical atmosphere to do it with amazing people, many of whom are on this call today. So I definitely like to thank you, David, but I'm not going to let you get away with just praise here. And so as probably most of you know, David usually works on his own rotation project. And I think many of these rotation projects that you also mentioned, David, in the beginning, lay the foundation actually for a whole new world and set of projects in the field. And so I'm really expecting that, even with all these distractions that are everywhere and are coming up, that you will still continue to make sufficient progress on your rotation project this year. Thank you, David.
Well, thank you very much, Tanja, and I will try.
Yeah, Kim, you want to go next?
Sure. So I, very similar story to what I've heard before. I joined the University of Washington to work in Wim Hol's lab. I was 100% certain I was going to do drug design. And my last rotation, I thought, I didn't really know what I wanted to do. And David invited me into his group. I was honored. And I fell in love with the people. I really enjoyed the project. The project was starting Rosetta. So one thing I had to do was learn Fortran. I did a little bit, but because of David, he forced me to learn Fortran. I know that's evolved, I hope, into something other than Fortran. But recently I had the honor of going to a museum in London and seeing the Rosetta Stone. And I think I was naive to think it was a little piece of granite, but it's an enormous stone. And I think that's just how this project was too. I was a kid from Kansas that had no idea what I was getting into. I knew about the holy grail of molecular biology. Little did I know that, I'd be part of this great story. My project, I thought, would end when I could start to predict beta proteins. And so when we were successful there, I think the constant time David and I were thinking, how are we cheating? We were constantly going through the code, trying to figure out, how are we not doing this, appropriately? And it all turned out to be great. My last thing I wanted to say was that while I was a graduate student, there were 2 University of Washington faculty who said, I think you need to reconsider your project. You need to be doing something else because we don't see it as being very fruitful. And now they've, I think, hopefully learned, and I could see the potential in it. Now the whole world sees the potential in it too. So congratulations, David. I'm very honored to have worked with you. Thank you.
Thank you, Kim. And for those who don't know, Rosetta is Kim's name.
Great. Bill, you want to go next?
Sure. Yeah. Thanks for having me, David. Yeah. Super congratulations. Just want to echo what other people have said. I mean, I think Brian's email said, what's your favorite thing? And I was there back in the early days with Brian and Tanja and Jens and Jeff and Gautam, going to lunch with Gautam. I remember that, and Phil. And to me, I came to the lab from doing a postdoc on single molecule biophysics, and I had a PhD in physics, and I was not a structural biologist at all. And I was actually looking for a job in 2001 because my postdoctoral advisor had just been recruited to move to Germany, and my wife-to-be and I couldn't move to Germany at the time. So I went to see David give a talk about protein folding at the Fred Hutch. And I remember asking a bunch of questions during his lecture, and then we rode the bus back together and we kept talking. And I think he checked one reference and the next day offered me a job, which was pretty amazing. And I'm forever grateful for that. And the thing about being in the Baker lab at the time, and I'm sure it's still true now, is, the huge creativity, but also the diversity of expertise and thought from all the different people. So you learn from David, but also from everybody else. And at the time, you just heard from Brian and Tanja, they were major teachers in the lab. It was so fun for a person like me. And my reaction at the time was just what Tanja just said, that it felt like the beginning of an era where protein design and protein structure prediction could really be applied to biology and medicine. And I told David, hey, you guys just did so well in CASP, there should be some applications for this. And the benefit to me was when Peter Kwong from the NIH Vaccine Research Center, who was working on HIV vaccine development at the time, emailed David a query about, hey, we just solved the crystal structure of this broadly neutralizing antibody with its peptide epitope. Could you design a protein scaffold that might be able to re-elicit similar antibodies? David just forwarded me the email and said, what do you think? And we had some conversations about scaffolds, and then we just started doing it. And with Andrew Ban and Bruno and other people, we published some papers, and they've turned out to lead to they kind of got embedded in Rosetta. And so David was very generous in thoughts that way. Bruno came on in my lab, and Mihai came on in my lab in David's orbit, and we did flexible backbone protein interface design. David contributed a lot. And I guess the last, Bruno's gone on to do amazing things in that area. And the one thing that's really been validated in humans so far toward HIV vaccine design and more toward larger aims is called germline targeting vaccine design. And we showed 2 years ago that with this molecule EOD GT860mer nanoparticle, you could prime specific classes of B cells that you predetermined in almost all vaccine recipients. And the mini domain on which germline targeting mutations were added by Joe Jardine and also Dan Culp, that original mini domain was designed by Possu in my lab in David's orbit back in the day. And so many people contributed, and it was just always so much fun to interact with everyone and get ideas. And clearly for me personally, David's generosity in kind of letting me go to lead HIV vaccine design, even though it didn't really work for me to stay at the University of Washington. I'll obviously always be grateful for that, and for obviously for his continuing support and mentorship throughout.
Thanks, Bill.
Ora?
Congratulations, David. This is really, really exciting. So I want to talk about what Top 7 was for me. I remember when Brian was standing on the giving group meeting or something and drawing this picture. And for me, it was amazing to see that this is actually really going to be realized during the time that I was there, when Gautam solved the structure next to me, sitting next to me. And so what is really interesting to me is that this success basically showed two things. One thing, that you can actually do this, so we understand the biophysics, but it also showed what is very different in nature. And I think this bouncing back from design to nature is for me what is really, really interesting, because you can, on the one hand, advance and develop applications, but you can also, on the other hand, understand what is different in nature, what else do we have there. And so one of the things that is different in nature is that proteins also need to function. And that is what brings me to one of the part of the functions that you could say is proteins need to interact to do something. And this is also what characterizes the Rosetta community. It's basically people work together to actually achieve something. So I see these similarities. And I think one of the really amazing things is, this time that I spent in Seattle is really a time I would have never thought that, I would meet so many people that are until today my best friends, and I really cherish them, and they have helped me to enjoy science and enjoy life. And advanced science, I've learned so much from them. And the other thing that I wanted to say, I looked at what I had actually proposed to do for my fellowship when I was with David. So I had proposed to look at evolutionary conservation to see if we can see if residues that evolve and are conserved are near to each other in space and what they could do. And so I had two projects there, one to see if we can actually improve our decoy selection, to see if the ones that are conserved are near to each other. And the other one was to look at surfaces to see if they can actually describe function. And actually, I ended up going on to study protein-protein interaction. So it's really nice to see how things basically are focused on the same things also already today. So yeah, I want to end with the contact order thing. That's the first thing that I heard about, David. And so, yeah, so the contact order is something that has really increased since I know this community. And so thank you very much, David. I really appreciate this immensely.
Thank you, Ora. It's very nice.
And the berries.
And the berries.
Jens, you're next. And we've also been we've been reminded to stay on time. This was so much fun, though.
Yeah, sure, absolutely. I try to stay on time. So I think one of the privileges of working in science is that you can choose with whom you want to work. And I remember after like 10 interviews for postdoc, the last place I went to was Seattle. And I had sworn myself I'd go somewhere nice and warm for my postdoc. And when I was interviewing in Seattle, the sun was shining, and I was in San Diego before and it was raining. And I think that was the sign. And David, I said, I stay for 1 day, I don't have enough time. And David said, no, you stay for 2 days. And then the first words were, let's go for a walk. And we went through some walk, I believe we went picking up your kids from school. And on the way, we talked about how to implement conformational changes for protein structural refinement, I believe, the fastest and most efficient way. And it was, that moment when I realized out of these 10 people I talked with, all exceptional scientists, this is the person I want to work with. Just because not just the science was so amazing, but the personality really got me. Then I think Tanja was selected to take me for dinner, and she asked me if I want to go and have sushi. I had never sushi before in my life coming from East Germany, but I didn't tell her. I said, "You sure I like sushi?" And then this turned into this huge recruitment dinner because David came and 10 other people came, and I think we broke the bank at HHMI for that recruitment dinner. But to make a long story short, I mean, this was certainly the best time in my life with this team, with this people. And I think, David, you are an incredible team builder. You have a good way to select people, put them together in teams, motivate them, and get them to constructively work together. And your generosity also, your wisdom of, letting us, putting together with us this whole Rosetta Commons idea so that we don't run in all sort of directions, but we stay together and become this community that now pushes in this direction. This was incredibly generous. There are, a lot of examples where really good people failed to do that, and you were always ready to share your science with us and your ideas with us. And I think that is really what shaped a lot of what I am as a scientist. So thanks so much. This was and this is a wonderful ride.
Thank you, Jens.
You hanging in there, David?
Oh yeah, I'm totally hanging in there. This is the easy part. This is the fun part. Yeah, it's really, really nice to hear from everybody. I wish we had enough time to, we'll have to have a big party sometime. But it's really nice. It's really wonderful.
Okay, it's my turn. Congratulations, David. I really can't think of anyone more deserving of this honor. And I'll keep on time. So I actually, when I came to do a PhD in your lab, I wasn't originally considering coming to University of Washington, but I had read these amazing papers by Brian Kuhlman and actually Tanya's hydrogen bonding potential paper, and I thought they were just brilliant. So I felt like I had to make a stop at UW to meet you. And Summer and I both have similar stories. We actually met each other while interviewing for other universities, but we all both decided that you were so incredible and your lab was so incredible that we had to go to learn from you, learn from the best, and do a PhD in your lab. So it was really David that made us decide to come to University of Washington when we could have gone many other places. And I think probably one of the most striking things to me at the time when I was trying to decide was David had this real, it was very clear that David cut out all the noise and he really just focused on the science. And I had never seen anything like that in any faculty that I was considering to work with. And so I really wanted to learn to be more like him. And that's why I came. And he spent all his time doing science. And that's really what I wanted to learn to do too. So I think the other thing, oh gosh, I can't believe I'm talking so long. So everything seemed like it was possible at the time in the lab. And I think that was what made things so magical. Things like that we were working on were things like de novo enzyme design and predicting structures so accurately that we could phase crystal structures. And So I think that David really encouraged us to be audacious in our goals. And I really just wanted to say thank you for giving us such a special experience in our training. I try to carry it forward every single day, and I try to instill the same values in my lab. So I try to encourage them to be dreamers, much in the same way that we were dreamers back then. Thank you, David, for everything. And, you know, I mean, I really just, I'm just so happy. I'm so happy.
Thank you, Liz.
Sarel?
Yeah, I guess I'm next. So thank you very much. And really great congratulations, David and Brian and everybody around here. So I wrote a few notes because this is like, it's well past my bedtime. So I have to use my notes. After my excitement about the Nobel news settled a little bit, the first memory that jumped to my mind was a group meeting that David delivered around 2007. This was in what I think of fondly as the dark ages of protein design, well after the glory of Top 7, but just before de novo design of function actually started working. I was working on de novo binder design, and nothing I did actually worked. The proteins were barely expressible, let alone functional. So David started this group meeting by saying that he wouldn't show any data, but instead pose a question. This went so, suppose you're at a cocktail party and someone asks you what you do for a living, and you say, I study protein design. And it so happens that this person actually knows something about our field. So they say, oh, the field that never really works. What do you tell them? We all brought up counterexamples, but it was futile. The imaginary person in the cocktail party was just right. When the meeting ended, I talked to David privately, and I told him that what he said was completely true and completely scary. And this is when David told me something that I still carry with me. He said, yes, it's true that de novo design of function doesn't work, but that only means that the problem is huge. And when we solve it, we will have learned something very, very important. And with that one sentence, David completely turned around the way I evaluated my own research. The fact that I was unsuccessful, deeply unsuccessful, only meant that the solution would be much more meaningful when it comes. And David was right, of course. When we finally had designs that bound and neutralized the flu virus, David insisted that we find out what the biophysical principles that made these designs work were. The calculations that he suggested showed that the design surfaces were highly rigid and pre-organized. Essentially, that meant that they could not reconfigure to bind undesired proteins, demonstrating an unappreciated negative design principle. What I can say is that this fundamental point about the importance of pre-organization and negative design in active sites is the common theme for all of the methods my lab has developed to this day. So thank you very much, David.
Thank you, Sarel. It's great to see you.
Possu?
All right. Yeah. So I don't know where to start, because apparently by the time I left the lab, I kind of set the record for like being the longest running postdoc that was there. So if I advanced anything, I advanced the time spent in the lab. Of course, there are other people who have been there longer than I did, but at least as a people that turn through to get from postdocs, I was like setting the record. But one thing since I was there for such a long time, I don't know where to start because there's so many things to talk about. But I actually probably just mention a few fun facts. So one thing was that when I first interviewed for the job, and again, this famous walk that David took us to, he was asking me like, oh, what do I actually want to work on? And I came from Steve Meiler's lab, right? Like so I was actually been designing proteins for a long time. And then I said, I want to build molecular motors. And then I'm pretty sure like in David's mind it was like, oh, this dumbass doesn't know what he's talking about. Like we won't be able to do that until much later. But what happened was that he actually suggested that we shrink this motor domains and see if we can miniaturize things. And that actually turned into the EOD and all these other cool de novo proteins that actually came out of it. And it just maybe anecdotally, oh, I'm running out of time so fast, and then later on, actually, it's very inspirational because I remember still like 15 years ago or something in the old building that David told me that his vision was really to build these de novo proteins, and you can just go like all off the shelf and take parts and assemble things to do new function, and that's exactly what's happening here. And then, maybe just the last thing I will share on my personal note. So I would thank David, and definitely congrats on like the well-deserved Nobel Prize, because I would not be here without David. And that's like absolutely true, because I almost quit because I actually remember having this conversation with David in his office after I have a round of job application that actually didn't go anywhere. And I'm still very proud of myself. I say I have all these skills and I like all these other things to do. I almost quit to say, oh, I'm just going to go make some violins for the rest of my life. And then David just basically told me, asked me 2 questions, and that completely changed the trajectory. He said, okay, how many violins are being made every day in the world, right? Like I was like, oh, I don't know, maybe thousands. And then he just asked the second question, and how many people can do what you do here? And then I was like, okay, I got your point. I'll try to apply the next year. So then that is exactly what brought me to this place. And then I absolutely am grateful to all the things that you have given me and all the opportunity and like the fun friendship and everything. And I'll just stop here. I already run out of time. Sorry.
Thank you, Possu.
Summer?
Hi there. First, I want to say how happy I am for you, David. If I recall, David didn't really like to have his picture taken and posted everywhere. At least that's what he told me after my defense with pictures of his face everywhere. But I really, really enjoyed seeing the photos last week on Twitter and enjoying my lab members and seeing how happy you were for good reason. And I also wanted to really thank David for his mentorship during my time in the lab. I really loved it, and he's a great role model. I think his enthusiasm for science and optimism are incredibly infectious. And I try to be like him as much as I can in my lab now. And I actually find myself thinking about him almost every day, actually, because I wander into the lab and I say, so how is it going, to everybody who I run into? And I recall that David definitely used to do that. Maybe his lab's a little big now, but that was definitely one of my memories, is just talking about science as often as possible. But I also do want to say there's some danger in how infectious this excitement can be. So a couple years after I left the lab, I switched over to zebrafish neurobiology, and I met him for dinner on a rare trip to Boston. I was deeply in my neurobiology world, but then I spent the next 24 hours after dinner thinking that I should start doing protein engineering again, just because of how excited David was and how convincing he was that all the challenges were solved and how bright the future was going to be. And I definitely think that David was really right, clearly, about how exciting the future is going to be. I think that was probably 2015 or so, and it's just incredible what has happened since then. And I'm really amazed at how much he has pushed the field forward. So congratulations.
Thanks, Summer.
Neil?
I think I'm next. So congrats again, David. I just want to highlight kind of 3 somewhat overlapping points. And want to start by coming back to what Tanja and Sarel both said, where I think everybody that has come to the lab has felt like they were kind of joining this thing that was happening that was just at the beginning. But it wasn't always clear where it was going to everybody, right? And I remember, during my PhD, I developed ideas. I wanted to design self-assembling proteins, and here's how you're going to do it with the building blocks. And I was told, oh, protein-protein interface design doesn't work. And when I came up and interviewed for a postdoc in the Baker lab, Sarel had just designed the first de novo protein-protein interface, and I saw it and I became incredibly excited because I knew that, this wasn't a crazy idea and maybe this could work. But I think that just highlights how David can build the future, right, in a way that I've never seen anywhere else, can visualize a future that doesn't exist and that other people can't see, and then he goes and builds it. And then, when that happens, that segues into point number 2, where this is how we do things every day here at the IAPD. Tech builds on tech builds on tech builds on tech, right? Sarel designed that first protein-protein interface, and then it spread like wildfire. And that was one of the enabling technologies for designing self-assembling proteins, right? We had to build on that. But the speed and the openness with which things build on other things, it really just comes from David setting that culture of openness and sharing. And then the last thing, and I think you're hearing and seeing in everyone's smiles today, just the generosity and the way that David lifts every single person around him up. And it's so much more effective than I've ever seen anywhere else. And I think that's because it is both deliberate, but also instinctual. David just instinctually lifts everyone around him up and makes them better. And this community, I think, has done amazing things because of it. So congrats, David, and thank you.
Thanks, Neil.
I guess I'm next. So, hi, David. Congratulations. I'm so happy for you. I don't think anyone else is more deserving than you for this prize. So I'm really, really happy for you. So I guess I joined the lab at a time where things kind of started to accelerate. And it's been really so amazing and also so intimidating to see all of these kind of challenges starting to be solved one after the other, and also all the brilliant people that were working there. So and everyone was so kind. I think this is what really struck me is it's really the atmosphere and the solidarity and just kindness. So and well, regarding protein design, sometimes it's still, I think Tanja mentioned that it still feels kind of like magic, right? So even after doing it, after so many years of doing it, sometimes I still can't believe that it's still working. So every time that I think we solve the structure and we see that it's matching what we are expecting, it's such a magical moment. And I guess I also wanted to take the opportunity to just highlight how really grateful I am for David to always have been so supportive of everyone, so I guess I've actually become a mom when I was a postdoc in his lab. And it's been a challenge, right? My family was living literally at the other side of the world. I don't think I would have been able to do everything I've done, having a baby, and working for another boss. So David has been always super supportive and sometimes pushy when to encouraging me to do things that I did not dare to do. And seeing him trying to always do trying to always make this scientific community, the Rosetta community, but also like the scientific community in general better for many people. I think this is super inspirational for me. So congratulations again, David. I'm really, really happy for you. I also wanted to say that last year I've been to Stockholm for a conference, and I've visited the place where they have the dinner, and it's so super formal. It's really, really formal. So if someone is there, I want pictures and preferably movies if you can. Share it.
Thank you.
And the ballroom dancing.
Okay, I think the next is me. So first of all, congratulations, David. It's been my great honor to work with you during my postdocs. So while I was in your lab, I actually developed the Rosetta for the AI method for protein structure prediction. And I always remember how you kept asking questions until you fully understand the meaning of the pieces I introduced. So thanks to that, I was able to think more deeply about domain-specific issues and integrate them into the AI, which proved to be incredibly helpful. So I have two remarkable moments. So first one is when I first joined the lab, I was really surprised to see you personally working on deep learning project, predicting Ora atom energies just starting from the backbone structures using the deep learning. And it was actually the first time for me to see the PI actually working on his own project while keep having discussions with more than 100 people. So it was really amazing. And another memorable moment is I actually received an email from you asking for my phone number in the middle of, I think, weekend. And that's because you have just have a new idea, and while trekking some trail in the middle of mountain with your family, when you cannot just wait until the Monday and you just wanted to call me just to discuss it right now. So that moment made me realize just how deeply you love research. And I'm really grateful that you taught me how to enjoy research and collaborate with others along the way. So thanks, David.
Thanks, Minkyung. Thank you.
David, congratulations. I'm so happy for you. It's been such a crazy week, and it's just, I'm so glad that this has happened and it's happened at this time. And, you know, I celebrate you and I celebrate the whole community that you've created here. So let me think. I joined the lab. I was a chemical engineer. I think I was the first chemical engineer in your lab at the time, and I worked on self-assembly of particles and how structure forms properties. And you know, they had these models of spheres that were charged that were supposed to be proteins and would explain protein absorption, but they were so pathetic models. And so one of my mentors, George Georgiou, said, you should go check out David Baker if you want to make better models of proteins. And then the people at Hopkins, the chair of chemical engineering here, said, I've never heard of David Baker. That'd be a terrible mistake. You should work for somebody famous. So I ignored that advice and came to work with you because there were so many incredible people. And I remember, let's see, you were trying to decide, you know, what is your role and how do you describe that? I think your role sometimes could be described as like a protein. There can be many different things a protein can do. And one thing you are is a transporter. Like you would come to me and we'd be talking about something and you'd say, well, you know, how do we represent proteins at a low resolution? And you'd say, we need to go talk to Ora. She's collecting the statistics. Or what is this? Does this protein interface look any good? And you said, go talk to Kira Bizura. She's a crystallographer and she could teach me how to look at it. Or I had done some electrostatics and you'd bring me over to Alex Morozov to talk about the electrostatic model. So you were this transporter moving all the pieces together. And then the other way you're like a protein is you're an enzyme, and that you were lowering all these barriers. We're coming from these interdisciplinary traditions, and you made us talk to each other and figure out how to get over those barriers. And then you were helping us find these global optimum and find these solutions and find these unique new ideas. So I don't know, yeah, you could be a protein. I also think of you as a coach. You've influenced me so much in how I train my own lab and even how I coach my soccer team, and how you always want to build off of everyone's positivity and have people teach other people and build on, as I think Bill mentioned, as each technology, each thing you learn, you build on that and go further. And it's just been amazing. So I'm super grateful for your example, for allowing us to participate and just allowing us to make this amazing community. When we went off on our own to start our own labs, you know, instead of having to build our own thing, you said, let's just keep doing it together. And so, yeah, I count so many of you here on this call as some of my very best friends of my life. And it's personal and it's also scientific, and it's been really special. So David, thank you for creating all that. And you know, this prize is well deserved. You're amazing. Thank you for all the work you've done and for sharing this with us.
Thanks, Jeff.
Okay, I think it's me. Well, first, congratulations, David. It was a great day for me too, so I'm sure that you had lots of fun. And second, I would also congratulate to everyone that came and become your members, because look at them, they're all amazing people. So you generally create a new environment that people love each other regardless of where they are. I remember that when I came to the lab, David and I both was working on cyclic peptides, and they both was learning Python. So that was a really great experience for me and him. And it was so funny because I would ask him, oh, why did you do that here? And he was like, let's sit down and think about it. And that was a really great project and a good experience. So I don't want to take too much time, but thank you again. And yeah, to the better future.
Thank you, Parisa.
Well, I guess it's me to close the round, I suppose. So congratulations, David. I guess this has been such a bunch of like joyful days just to see all this happening for so many years, and now sort of like, with this moment. But going a bit to like my personal experience, when I got to the Baker Lab, I think I was clueless. And obviously, David picked it up in the first 10 seconds of our conversation that I had no clue what I was doing there. And so what he did instead, he was like, he pitched me to Bill as being the smartest man in Portugal. That's exactly how I was pitched. And so Bill took me, and then I guess, we got to do a few things. And eventually I get David to Portugal, and he actually figures out that there's a lot smarter people in Portugal than myself. But we do have a conversation about sort of like, well, look, what kind of things should we do, and this and that, while we were stuck in the traffic. And then once we are in his office, and he just kind of tells me this one thing that kind of changed my life in a way, which was, look, you've done what I asked you. Now you can behave as a kid in a candy store, and you can just pick and do whatever you want. And that was a lot of fun, I tell you. So this is sort of like speaking about lifting people up, right? So I think when I think about this Nobel Prize, I don't know many Nobel laureates which you could go randomly on this list of achievements on how many things this Nobel laureate has done, and you could remove 50% of them, and that person could still be a Nobel laureate. I mean, who on earth does this? I mean, nobody does this, right? Sort of like, you could just do this, but it's also just like a Nobel laureate, and the words have been there. It's a Nobel laureate of generosity. It's one person that has decided to do it differently. He could have just done it all by himself. But in a way, he decided that it was a better solution to do it differently and open it up and generously letting people participate, having fun. And to me, this is what this Nobel Prize is about, and to me, this has been what this life experience together with this community has been about. So I'll leave it at there. Congratulations.
Thank you, Bruno. And I just have to disagree. I couldn't have done it myself. I couldn't have done anything myself. So
thank you, everyone. I think Ian said there was a couple questions on the chat that he was going to read out.
I'll speed run through a couple of these in our few minutes remaining. You ready, David? All right. So first one from Kettner Griswold. David, as a community, we have made progress in the past year or so in realizing multi-state design, enzyme design, and other challenging design tasks of interest to this community. What comes next?
Well, I think as many people have said, we're really just at the beginning. There are so many amazing things that proteins can can do or will be able to do. So I think really the sky's the limit, and all the wonderful people on this call are exploring, totally different directions and things that proteins can do. Just for one example, like Possu mentioned, designing protein machines, and I think this is the next few years. I think we'll start seeing more and more complex protein machines that can do more and more amazing things in in health and in technology and really everywhere. So I think we're really just at the beginning, and it's going to be a very exciting next years with everyone here working collectively on it.
Thanks, David. And one more quick from David Ninneman. It's amazing how many ideas from the early Rosetta years are relevant again in the ML era. Evolutionary information, scaffolding, etc. What else can we recycle, pun intended, into the new generation of algorithms?
Well, I think almost everything, because what I think we really did as a community when as the deep learning methods were being developed is, we swapped out to some extent what was under the hood, or we had kind of like a car. You have like a gas-powered engine, you have electric cars, and then you have sort of the hybrids, but still driving a car is the same. And so I think the way that we ask questions and the sorts of questions we're trying to answer really have stayed largely the same the way we go about trying to solve problems. So I think we just got, we got a more powerful engine under the hood now.
That's great. Maruf Hassan writes, congrats. And what advice do you have for a new PhD student, say in computational biology, if they want to make impact?
I think my advice generally is to just try and do whatever you're most excited about at the time, and don't worry too much about the future, because I'm kind of skeptical about the ability of, at least my ability to predict the future. So I think if you just do at any time what you seems most interesting and exciting to you, I think that's a pretty good recipe for moving forward.
All right, in our closing moment, Sergey Lyskov writes, when you published the original paper, did you have a feeling it was going to be, or it was, a major breakthrough?
I want to pass that one back to Brian.
All right, let's throw it to Brian. Thanks.
I was certainly excited. I mean, but clearly, everything that's come after is even cooler. So yeah.
And I thought it was really exciting too. But I don't think any of us anticipated what the next 20 plus years were going to hold. So it's just been absolutely a wonderful and an honor to work with everyone here. And this is, I have to say, it's been one of the most fun things about the last 5 days or however long it's been since Wednesday. There's been a lot of pretty exhausting and stressful things, but this has been really, really nice. So thanks everybody for coming, and yeah, it's really been wonderful working with all of you.
Thank you, David. I guess that concludes.
Thank you, David.
Yeah. Oh, thanks everybody.
Thanks, everybody.
Thanks.
Thank
Bye,
you,
David.
everyone.
Congrats.
Thank you, David.
Great to see you all.
Good one.
Yeah.
Thanks, David. Amazing, amazing, amazing.
Yeah, thank you.